So why is it that the derivative of x squared is equal to 2x? Well, we kind of justified it a little bit in that the derivative of a quadratic function tends to be linear, okay, because the changes of a quadratic function are linear changes. But we can also look at this from a slightly different perspective. So if you take a look at what is x squared, well, x squared is a function that calculates the area of a square given some side length x. The input is x, the output would be x squared, which would be the area there. Okay, so that's what x squared actually calculates. So it is the area of a square. Well, dy by dx then, if xy is x squared, dy by dx means the change in the area as we change the length x. Okay, so dy by dx is a change in area over the change in length x. So as we change the side length x, so here the white area represents the original x squared, what we're starting with, and here's my side length x, and the change in x must be then an increase in length along this length and width. Okay, so we've changed the length a little bit and changed the width a little bit. And dy by dx then is, what is the change in area as we change those x's? Well, the green then represents the change in the area. So what is the change in the area then? Well, if you take a look at it, we have these three pieces of area that represent the change. And this area is going to be represented by x, so the length here is x, times this little bit of width dx. And this bit of area is the same. It's going to be a length x this way and a width a little bit dx this way. And then we also have this little dx times dx. Now, I've kind of drawn it exaggeratedly, but as we let dx get really, really small, because that's what it really means, a small change in x, that dx by dx, that square becomes smaller, it becomes really, really tiny. It essentially becomes insignificantly small or negligibly small. So that's what I've written over here. So the dx times dx becomes negligibly small. So the change in the area function then must be represented by these two x dx parts. Okay, so the change in y then must be this 2x dx. And then we could also rearrange it and just say, well, the change in y over the change in x is going to be the 2x function. So there it is. So we have the change in the area over the change in x. Essentially, we're going to gain a little bit of x here and a little bit of x here with negligible width, which gives us the change in the area as we lengthen x. Or in fact, that also can be represented by shrinking x as well. Okay, so the same similar explanations given in the video. They give you, I think, a slightly different perspective to it, but the same idea. We can look at these pieces geometrically, and when we can. Sometimes we can, sometimes we can't. But when we can look at these things geometrically, we want to try to do so. This fits right in our model of our grid multiplication. Okay, so this is how we understand multiplication and understand squares. So we should really try to apply that and see how that relates physically or geometrically to this.